A few months ago I posted a video on how I use a TIG torch as one method to straighten thick pieces of steel. And I mentioned at the time that was for a project I was working on where I was converting an old diesel mower into a forklift. And I've been asked to show a few more details of that. It's not really the normal content for my channel, but some people were interested, so I thought I'd post this video. So this started life as a Kubota mower, one of the old diesel ride-on mowers, and I started by completely stripping it down. In fact, that's the remnants over there of the mower. Excuse the mess in here. This is just an old workshop I'm working in. It's used for this sort of project, but it's a bit untidy in here. Lighting's not too good, but hopefully you can see what I'm doing. So the first thing I did was to completely strip the mower down to the chassis and try and decide how to best go about converting this. So there are a few things that I needed to consider. The first one was what was the lifting capacity I was aiming for, and I wanted to be able to lift about 1,000 kilos up to a height of maybe 4 or 5 feet. So single stage mast was going to be fine, but the first thing I had to consider was reversing the direction of travel of the mower, because obviously with a forklift we want rear wheel steering, but normally the mowers are of course front wheel steering. So the small wheels that are now at the back were originally the front wheels. The engine's always been at the front, but what I had to do was completely reverse all the controls. And it's hydrostatic drive, which is this thing sitting down in here, and the pedal cluster, so pedal and brake, these were over on the other side of the chassis at the other end. So I had to move it over to this side so it was in a suitable location based on where I was going to put the seat, and then come up with some linkages and rearrange it so that forward was backwards and backwards was forwards. In other words, when I push the pedal for forwards, it effectively makes the machine go what used to be backwards, which is now our forwards, of course, because this is now the front and this is now the back. That turned out to be a bit more complicated than I thought, but the most complicated bit so far has been the steering. Now, the mower, unfortunately this mower doesn't have any hydraulics, or didn't have. All my other Kubota mowers have hydraulics on them for the tilt, the tip, the raise, but this one didn't. It's all electric, including the power steering. Now, I didn't want to start off by going to the expense of replacing the electric power steering with a hydraulic power steering head. Now, I have bought a cylinder that I can use, which is what this one is sitting here, that will ultimately, I should think, go on here. But just to get this up and running and see if the concept was going to work, I ended up reversing the direction of operation of the electric power steering. And that turned out to be quite a complicated task. I even had to take the steering rack apart and machine it so that it kind of worked in the opposite direction. Made this cross link, and that now actually works fine, but was a bit of a pain to get it to work within the restriction of what I had to work with here. But that's now working fine. Completely stripped out and redid the wiring loom. Most of the wiring was for things I didn't need anymore, PTO clutch, that sort of thing. So rather than just cut the wires off, I completely opened up the loom. But it was a strange arrangement on these. There's a lot of splices inside the loom itself, so that was a bit complicated. And a lot of the wiring is actually for the power steering. That's what this control box is on the front here. And then we have the safety circuits, which most of those I didn't need anyway, so I took those out. Redid the loom completely, simplified it, and now that's all working fine. Let's get the seat out of the way. I made this frame up that the seat and the rear covers will sit on. Let's get the seat off. It's not bolted on yet. So this frame holds the radiator. The radiator used to sit at this end of the engine inside the plastic cover of the machine, but I wanted it at the back. Wanted the fuel tank here. I want to keep the weight as low as I can on this. It's a forklift, so we need to keep the weight low down. So I've moved the battery down, made a battery holder for it. You can see it sitting down there. in the bowels of the machine. There were certain things that were quite complicated to do. I changed a lot of the metalwork. You can't see it. I didn't shoot any videos as I went, but this has been completely changed now. It was of course facing the other way anyway, and this whole assembly was bolted on here facing that way, and it was completely the wrong shape for this end, so I completely changed that, re-welded it, made it all fit together. But one of the main headaches on this end was underneath here. You can kind of see it down in here. You've got this PTO gearbox, an intermediate gearbox, and there's a belt at the top that drives the hydrostatic drive system at the back here, but on the bottom side of it there is a shaft coming out that had the electric PTO clutch attached to it. And of course I removed the clutch, but hadn't realised at the time that that whole assembly is then floating. That clutch bolted on the bottom actually holds everything in place. When I tried starting the engine, I just had oil running out the bottom, which turned out to be fairly fortunate, because I ended up taking the gearbox apart, see what was going on. I don't know why, but it was full of water, and if I'd left it like that it would have destroyed itself fairly quickly. I hadn't used this mower for quite a few years. Had it a long time, but stopped using it 4 or 5 years ago. And stripped the gearbox down, figured out that I need to make a kind of a blanking plug and collar for the bottom so I could bolt it back in. Changed all the bearings, changed all the seals, and that's now fine. So that then, once I'd got this running and driving in the correct, what is now the correct direction, the next thing was to actually turn it into a forklift. And the main consideration was making it strong enough to actually do the job. And what I'll take one of the wheels off so you can see what I ended up doing. So with the wheel removed, you can hopefully see better what I've actually done here. So the issue really was that I'm attaching the bottom of the mast. We'll have a look at the mast in more detail in a minute, but the force from the mast comes down onto this pin. This is a single pin, goes all the way through, and this is the main pivot point and mount for the mast. The whole mast will pivot, and that means that the force was going to be transferred to the chassis, and it would have originally gone through the chassis onto the hydrostatic drive, and the wheels obviously bolted onto this hub. But one of the issues is that originally there's about a 5 or 6 inch length of shaft sticking out of the hydrostatic drive. It's a 1 inch diameter shaft, but it's quite long, and it comes out of a fairly thin aluminium housing that's part of the hydrostatic drive. You can possibly see it sitting under there. But the shaft is kind of just bare from this point out. There's nothing supporting it. So if we tried lifting a ton of force, now these mowers are fairly heavy. I've removed about 150 kilos from this, but I've added back about 150 kilos. So it's about the original weight. Now they will take a collector bin and various bits and pieces. So they'll probably carry another quarter a ton, 250 kilos. But that's nothing compared to what I wanted to lift with it. So I had to be fairly cautious here, and if I'd left it as it was and tried to lift a ton and transfer all that through these shafts sticking out of the hydrostatic drive, it most likely would have just snapped the shafts off the drive. So I couldn't really leave it like that. So what I've done, and it's again quite difficult to see, I've started off by putting these cheeks, or 12mm thick cheeks, onto the side of the original chassis. So that's all welded directly to the chassis. There's some inner pivot mounts as well that go onto this front 10mm thick plate. And then there are these collars, one here, there's one on this part as well, and the same on the other side. And then there are these gussets that go all the way down to this flange at the bottom that are welded directly to the chassis. This transfers force along the side of the original chassis and comes through to these gussets that go down to this 12mm plate. Onto this is all welded as a kind of box section, and we have gussets under here as well. So this is kind of a rigid structure now, and the weight from the mast comes down this. It doesn't go through the hydrostatic drive. This outer hub is kind kind of hub you'd use for a 2-ton trailer, that sort of thing. So this has a pair of bearings in it. The original bearing, of course, is still in the hydrostatic drive. And this is actually the trickiest part of the entire build so far, is getting this lined up so that this would still spin freely once I'd welded all this up. Welding thick steel can cause distortion, but I needed to make sure that it was lined up properly after I'd welded it so everything turns freely, which, as you can see, it does. So there are now these two bearings, the outer bearing sitting here just behind the hub. In fact, the hub touches it, so that's as close as we can get to having the bearing right up against the back side of the hub that the wheel bolts to, so we don't have this extended shaft sticking out and cantilevering all the force from the drive. So the force comes down from the mast along here, through this structure, through this hub, and onto our hub that the wheel's bolted to. So it should be plenty strong enough for what we're doing here. Like I said, the main issue was trying to get this lined up so that after I'd welded it, it still spun, and obviously the other side is exactly the same. I also included, again you can't see it, but where my finger is here, there's a slot that goes up, that's the width of the shaft. So if ever I need to get the hydrostatic drive out, I can. It's not permanently welded in place now as it would be if I'd just made holes in this place. So this has got a kind of a keyhole slot in it. And also, of course, I can take the hubs out that's bolted on. I reverse them as well. Take these nuts off. I can then slide the hub out. If I need to get to the bearings, there's also a grease nipple that I can use to grease the bearings that sit inside this. So that all worked out fairly well. It's a bit complicated to get worked out, but it's all gone together well, and that now will give us plenty of support for the mast. You can see here this weird linkage I had to make up to get the pedals to work. It's actually no more complicated than the one that was on the mower originally. It's just different configuration because I've reversed everything. Again, it was just a bit complicated working out where everything had to go. So the next thing, once I'd got the pivot point and strength for the chassis sorted out, was the mast itself. Decided to go with a single stage mast. Don't need particularly high lift on this, it's mainly to move things around, and we have to get heavy objects across our paddock every so often, which is why I wanted to retain these big wheels as our now front wheels. I will need to get them filled with semi-rigid foam. If one bursts while we've got a load high up, the whole thing would tip over, so I need to get those filled. So I made the mast from these C-section channels. They are around 2 meters tall, and they will give me a total lift height of about 1.6, 1.7 meters, because it can't go all the way to the top, of course. This is all running on bearings, so there are guide bearings and thrust bearings on the inside of this. There are also bearings that run on the outside edge as well to guide the carriage up and down the channels. Again, you can't really see that well, but there are 4 bearings on each side, plus the outer bearing. And it runs very freely. It's, when it's not on here and there's no weight on it, it will just run back and forth quite freely. Now, I arranged this so that the forks, these forks came off an attachment for our mini digger, and I wanted to use professionally made forks. I didn't really want to risk making those myself, but I wanted these to run all the way in and out, so I can put them right into the center or fully out. So these will run quite freely all the way along here, so they're not rigidly attached. It will move all the way along. And I've arranged this so that we have our side cheeks here for guiding. We have the main lifting thrust from the 2 chains coming onto this plate. It's a 15mm piece of plate. It's got these side gussets. There are also gussets on the underside of this welded to this front plate, and these go all the way down to the bottom cross piece, as do these side ones. And you can see that the bearing rods, these are what the bearings that run in the channels are on. These come all the way through to this inner face on both sides. And so we have these 2 12mm thick plates on the front that take the force from the forks, transfer it to these 2, and to the main lifting rib, which is this one behind here. So it transfers all the load evenly and should give us a nice strong structure. Again, it's probably overkill for the weight we're aiming for, but I wanted to play safe rather than having something that may fail on me. So then on to the where I was going to have this lift, and by the way you can see the other end of the pivot pin here and the other side cheek. So the whole mast, I can't move it now because we have the rams attached, but the whole mast pivots back and forth as a normal forklift would, so we can tilt the forks backwards and forwards as well as raising them. So the next thing was the lifting mechanism. So I've gone for a single cylinder, and the height of this cylinder is such that I'm using about 80% of its travel. I could have gone taller on the mast, but the reason I haven't is single stage mast, and I wanted it to fit inside this shed. If I'd gone any taller, it wouldn't have gone underneath the cross beams in here. So this is as high as I could make it, but it's more than adequate for what I want. It will easily reach onto a lorry flatbed, which is the height I was aiming for. I've gone with 430 sized 4/4 chain. These are proper forklift chains. Each one of these is rated at 3,700 kilos. I've gone with two. First, because it makes it easier to arrange the way it lifts. It's not going to rock from one side to the other, and I can obviously tension them individually to make it lift squarely. But it gives me a total, in theory, lifting force of about 7,000 kilos, which is my factor of safety for this is 5, so that's well in excess of that. Tricky bit to make with the mounting point. You can buy these, but they're expensive. So I made these from 12.9 grade bolts. Quite difficult to machine. But I made 4 of them. There are these 2 that sit down here, and there's a nut on the underside, so I can adjust it. And then there are 2 more at the other end that sit up here. Get a better view of what they look like here. It's was a big cap head bolt. As I said, 12.9 grade, so very high grade. And the overall strength of this should exceed the chain. Machine these out, very tricky to machine narrow slots in such high grade steel. Made these, and again there are nuts on here so I can adjust this if I want to. Okay, so we'll look at the way the chains run across the top of the ram. And I made, again you can't see them, but there are 2 bearings in each of these pulleys. And I machined these from a solid steel bar, and so we have 2 large 60mm bearings, one on the outside, one on the inside, and then this pin goes all the way through. And these of course run independently. They run separately. They're not spinning the bar, they run on the bearing, not on the bar. Chain runs around these, so the lift of the forks is double the travel of the ram because of the way this is arranged. So the ram only needs to move half the distance that the total lift of the forks will be. It's a fairly typical arrangement for a forklift. So this will allow us to take the carriage all the way to the top of the mast. With this diameter ram and the pressure of the system I'll be using, the total lifting capacity in theory using this ram is about 4,400 kilos, and that's with the pressure setting I'll be using on the control valves, which I'll show you in a minute. So that will easily give us the lifting force we're aiming for, and I can also limit the lifting force to make sure we don't rip the thing apart. But this whole arrangement should easily be strong enough. Now the bottom of the ram comes down here and it sits on these 2 flanges, which are bolted directly to the back of the mast. There's a big cross piece. That's the piece I showed straightening in the previous video. And the presence of these 2 flanges is why I couldn't just press it straight. So we've got a pin going through here at the bottom of the shaft. The hydraulic connection you can't see is on the back of here, and it goes through the chassis, and will go to our hydraulic control system. So this all now works very nicely. The final thing to arrange was the tilt. So we have this mounting plate here that's welded to the back of the uprights. Got the gussets in here. This is very thick steel, and we have the gussets on the underside, so this will be easily strong enough. But I decided to double this up and use this as the mounting point for the tilt cylinders. I could have got away with using one, but it was just easier to put two on here. And it also allows me to make sure it will move squarely. It's not going to start trying to twist if there's any imbalance anywhere. So these two cylinders will allow us to tilt the mast back and forward. It's in its fully out position at the moment, so if the wheels are on the tips of the forks, it's on a raising table here, but if it was on the ground and it had the wheels on with the mast and it's fully out, tipped forward position like this, the tips of the forks would be touching the ground. And I've arranged the geometry of all this so that the forks will go all the way to the ground with about probably 10-15 millimeters to spare. Bear in mind the tyres will compress when we start picking a load up. Okay, so the next thing was the hydraulics. This is the last thing I have to work on. I haven't done any work on this for a couple of months, by the way. It's about to get back onto it, which is why I decided to shoot this video. But the final things to do: tidy up the wiring, make a control panel mount, just a piece of steel or something to mount the controls onto, and the warning lights, that sort of thing. I need to mount the hydraulic pump. This is the pump I'll be using. Picked a size and flow rate that will give me 8-second total travel time for the lift. That is 8 seconds from all the way down to all the way up, based on the expected flow rate with our given engine speed and the pulleys I'll be using. So this will actually mount underneath this arrangement, and it will be driven from this belt. So there's now a spare pulley at the top of here. It was used for something else on the mower, but I'll be using this with a short belt to drive our hydraulic pump, and the pump, as I said, will sit on a plate that I've still yet to make and weld in underneath this assembly. And the final thing, of course, will be the hoses and the control system. So I have the control valve, so a double control valve. One valve will control the lift and the other one will control the tilt. If I ever need to or want to, I'll get a hydraulic steering head, fit the hydraulic steering ram, and use hydraulic steering, which will actually work a lot better for a forklift than the electric one. So this will mount up here. I just need to make a mounting bracket for it that will weld onto our steering column assembly here. And then it's just really a case of getting some hoses made up to the correct length, get it all plumbed in, fit a hydraulic tank. The hydraulic tank will be fitted in here onto the back of this plate. And then that's it. It should, in theory, give us a fairly useful forklift. If you're wondering, normally this cross piece rocks. It's part of the rocking motion single point pivot that the mower had. But I've welded this up solid. It's welded here. It's welded on the inside as well, because of course, forklift, we don't want it rocking about. That would be dangerous. So this is now rock solid. It's not going to tip anywhere. Probably put some running boards on, a floor in it. Probably just put some wire mesh around the outside of the engine. This does all run. I have run it around and it works fine. And it should give us quite a useful addition to the workshop. If you want to see any more of this, you want to see it running, then leave a comment. Got any comments or advice or anything you've seen that you think needs addressing, then again, leave a comment.